Okay guys, just looking at that last example again, which is dealing with true bearings and using sine rules and cosine rules to find missing sides and angles. So just to draw a picture again, we have got a ship that sails on a bearing of 38 degrees. So I draw my rosette with the north, and I get a different color to show my ship sailing along at 38 degrees for 3,000 meters. Okay, and I put in a little 0.38 there. The next thing that the ship does is it sails on an angle of 318 degrees, 3,300 meters. Now 318 degrees, if we look back at our rosette, we can see that it's up sort of in this direction, sort of a northwest direction. So we're going to have this ship head off. Oh, dear me, that's very quick. Let's try again. Head off in a northwest direction of about 318 degrees, and that's just as wobbly. Sorry, guys. And that goes for 3,300 meters. Okay, and we add our degrees. Now it measures from true north all the way around to there, and we get 318 degrees. Okay, so question A wants us to find, and I'll mark it in green, this side here. It wants to find the line A to B. Now straight away I'm looking at that and I see we've got two sides here. We've got a non-included angle. Now this means we can use the sine rule, and to find the sine rule, that would then give us this angle, which means we could work out this angle and then work out the side. That's a bit long. There's actually a shorter way. When I looked at the question a bit more, we can work out what this little angle is quite simply. So if we look at that angle, we remember that this was 38 degrees here, and this was 318 degrees here. I'm just going to zoom up that rosette a bit. So there's our triangle zoomed up a bit, and I'm trying to look at that particular angle. So this here is 38 degrees. What that tells us, and I'll draw this in green, this extra information that we get, is because that's 38 degrees, we've got alternate angles here. So that means that that's 38 degrees too. We know that this is 318 degrees. So if we subtract that from 360, we'll get this value in here. And 360 minus 318, that's 42 degrees. Okay. So 38 and 42, and whatever this little bit in here, should all add up to 180 degrees. So let's work that out. 180 minus 42 minus 38 will give us, well, 42 and 30 add up to 80. So 180 minus 80 will give us 100 degrees. So that means that that value there is 100 degrees. Let's put it back in our bigger triangle. Okay, back to the original triangle, and I'm going to write 100 degrees in there. So now we've got two sides and an included angle. We can use one rule to find the missing angle. We're going to use a cosine rule. All right, so let's label our sides first. Now we're told down here is A and up here is B, so I'm going to call this one C. That gives me a way to label the sides, so that's a little c, a little b, and a little a. It can get really confusing sometimes, so it's good to use different colors. So we're looking for little c. And there's our cosine rule when we're looking for the side c. A squared plus b squared minus 2 times a times b times the cos of the angle c. Let's substitute what we know. It's going to be a long sum. So a was 3,300 meters. Square that. We're going to have 3,000 meters squared. We're going to subtract 3,300 times 2 times 3,000 times the cos. Oh, it's not going to fit. I'll write it here and then I'll move the screen across. Here we go. Times the cos of 100. And of course, then we've got to square root all that. Okay, let's plug it in a calculator. Okay, so that's what it should look like on your CAS calculators. Let's press enter and hope it works. we get 4,829.93 meters. That seems a reasonable answer, so let's put it in. Okay, now the question does ask to the nearest meter, so I'm going to have to round that off to 4,830 meters for our final answer. Wasn't that fun? Don't you love bearings? Okay, I think this is the last example question. And for this one, we have to find the bearing of B from A to the nearest degree. You have to be really careful about how you read these. Let's go up and have a look. Okay, so what it wants, and my diagram isn't great, I do apologize, is it wants the bearing of B from A. So it actually wants to know what the angle is down at this end. Now it can be kind of confusing because you've already got an angle written down there, you've already got 38 degrees written down there, but that's the true bearing of this line. What we need is the true bearing of this line, or okay, so we actually need to find the angle, the internal angle for A. And you can choose to use the sine rule from this, but I'm going to use the cosine rule because I've got 3 sides and I can find a missing angle using the cosine rule. So I'm looking for angle A. So angle A equals the inverse of cos, where b squared plus c squared minus a squared is divided by 2 times b times c. Let's fill in what we know. So it's going to be a long one again. Cos -1. Now b was, I think that was the 3,000 squared plus the 4,830 squared minus the 3,300 squared over 2 times 3,000 minus 4,830. Close our brackets. Plug that into the calculator. Okay, that's what it should look like on your calculators. Let's see if we get a reasonable answer. Any moment now, calculator. We get 42.2871 degrees. Now, that tells us the magnitude of that bottom angle, but it doesn't tell us the bearing. What we have to do to find the bearing is we'll have to subtract the bearing of the line that ran from A to point C, which was 38 degrees. Okay, so I'm going to round it off to 42 degrees because we can do it to the nearest degree. 42 minus 38 is 4 degrees. Now this means it's 4 degrees beyond, so 360 minus 4 degrees give us our bearing, which will be 356 degrees true. That's our answer. Okay, so hopefully that helps you with working out that last question. It is crucial that you practice your drawing skills with bearings, because after that you're just going back to your ratios and cosine and sine rules, which you should be comfortable with by now. Good luck. I'll see you guys.